Alright, ladies and gentlemen, we are doing Algebra 1 solving equations. This is kind of a review from last year. You did this at the beginning of last year, and you might remember it. You continued doing it throughout the year. We're going to start at the base like you've never had it before, so hold on to your hats. Let's have fun. Definitions: equation. An equation is a mathematical statement that two expressions are equal. So remember when we talked about expressions are numbers and operations put together. So you have two numbers and operations are put together and they have an equal sign in the middle. That's what makes them an equation. Equal equation. Alright, so an example of this would be 3x is an expression. They're put together by multiplication. 3 times x. 4 plus 2x. This is an expression also because it's put together with a plus sign and multiplication between the 2 and the x. What makes it an equation is when you have an equal sign in the middle of the 2. So now this is an equation. 3x equals 4 plus 2x. Now solutions of an equation. It's basically the value for x in this case that makes this statement true. So let's start off with an easy one. X plus 5 equals 10. Well, we all know that x is going to equal 5. That value right there makes the statement up here true. So it's a solution to an equation. Alright, here's some operations. Now when we solve any kind of equation for a certain value that makes it true, we use inverse operations. Now you already know what these are, but I wrote them down just in case. Here are the operations over here, and here are their inverses over here. So for adding, it's subtracting. For subtracting, it's adding. For multiplying, it's dividing, and dividing, it's multiplying. And you should know that, but wrote it down just in case you might need to see it visually. Alright, when we're solving, when in doubt, follow opposite PEMDAS. So instead of PEMDAS, you're going to do SADMP, MEP. SADMEP. SADMEP. Or ASAD, or ASAD, MEP. Or SAMDEP. Or Awesome depth. Anyway, PEMDAS basically. Now notice I didn't say you have to use PEMDAS. You have to use opposite PEMDAS. I didn't say that. You can actually go in any order you want to as long as you follow the right rules, like inverse operation rules. Whatever you do to one side, you have to do the other side. Those kind of rules. Now PEMDAS will just help you do it the easiest way sometimes. Sometimes it's not. But when you're in doubt, always use PEMDAS. Alright, adding. Let's do adding first. Now, these are easy. We all know that the first example is going to be 6. But when you do these for right now, what we're practicing is the method behind it. So you have to show your work. And this is how you show your work. First, you're going to set up a line right through the equal sign. The reason why you do this is because whatever we do to one side of the equal sign, we have to do to the other side of the equal sign. And this is why. For an example, if we had 2 equals 2, which is right, and we added 1 to this side, you would get 3 equals, well, it doesn't equal 2, so what you have to do is you have to add 1 to this side. So whatever you do to this side, you have to do to this side. It has to work that way, or else it's not equal anymore. So back to our first example over here. We drew a line through our equal sign, so we know that whatever we do to one side, we have to do to the other side. Now our whole goal is to get x by itself. We want x equals something. Well, we look at what's over there with the x. The 4 is over there. So what we're going to do is we're going to use opposite operations to get rid of that 4. So you see the operation that's there is plus, so we're going to subtract 4. Because 4 minus 4 is 0. It cancels out. Doesn't disappear, it just turns to a 0. X plus 0 is x, so basically you don't really have to write this 0 unless it helps you out, but the 0 disappears. So we end up getting x. Bring down your equal sign, and whatever I do to the left side, I have to do to the right side, so I'm going to subtract 4 over here. 10 minus 4 is 6. So my answer is 6. You can always check it out by looking back over here. 6 plus 4 equals 10. We're good. Alright, so let's do the bottom one. Line through the equal sign. We're trying to get x by itself. We have a plus 3, so we're going to subtract 3 from both sides. These cancel out. You get x equals negative 4 and negative 3. Two negatives. So that makes us negative 7. Negative 7 plus 3 is negative 4. Works out. We're good. Subtracting. Subtracting is basically the same thing. You're just using the opposite operation like before, which would be in this case addition. So negative 5 plus 5 is 0. It goes away. So we're left with x equals, add 5 to this side, 13. Let's check it out. 13 minus 5 equals 8. We're good. Checks out. Now let's do this one down here. Alright, so we have x minus negative 2 down here at the bottom equals negative 10. So the first thing you should do is this. You should change this minus negative into a plus sign. That way you don't have to deal with it anymore. Now, it's just like plus from earlier. We subtract 2 from both sides. We get x equals, subtract 2, negative 12. That's it. Negative 12 plus 2 is negative 10. Checks out. Alright, multiplying. Multiplying is a little bit different because its inverse operation is division. So what we do first is we figure out what's over there with x. We want x by itself. What's happening to it is being multiplied by 2. So what we're going to do is we're going to divide it by 2. Now if you were reducing this as a fraction, you know that 2 goes into 2 one time, and 2 goes into 2 one time. So you end up over here with an x. And that's it. X over 1 is x. So once I do that, I have to do it to this side, so I divide 10 by 2 and I get 5. Check it out. 2 times 5 is 10. Works out. We're good. Now let's check down here. Same thing. We're multiplying by 3. So I'm going to divide. Sorry, I forgot to put my line up there. I'm going to divide by 3 on this side and divide 3 by this side. 3 divided by 3 is 1. So you get x equals 16 divided by 3. It will not reduce. So guess what? You're in algebra. You leave it 16 divided by 3. You're done. Alright, dividing. Dividing is a little bit different. What you're going to do on dividing is opposite operation or inverse operation, which is multiply. So I'm going to multiply by 2. Now I'm going to keep it as a fraction because when we multiply fractions we do top times top, bottom times bottom. So it's really 2 over 1. Now I can reduce this. 2 will go into 2 one time. So I'm left with x equals, and then I multiply this side by 2, which is 8. 8 divided by 2 equals 4. Checks out. Now let's do this one down here. This one looks like the same thing. We're actually multiplying by half, but when you multiply by half, you're actually dividing by 2. So really, you can just multiply by 2 over 1, which is its reciprocal. Remember, reciprocal is a fraction multiplied by its reciprocal gives you 1. So 2 over 1 times 1/2 gives me 1x. So that means this side I'm going to multiply by 2 and I get 8. So x is 8 again. Half of 8 equals 4. Perfect. Check mark. Alright, now we have fractions. Fractions are a combination of multiplying and dividing. See, what's really happening here is you're multiplying x by 3 and dividing x by 2. So you're doing a combination of both. So really, to get rid of this fraction, you turn it upside down and multiply by its reciprocal, because when you multiply by its reciprocal, you get 1. You'll get 6 over 6, which is 1. So I have to do the same over here. I multiply by 2/3. Change 12 into a fraction. Top times top. Bottom times bottom. 24 divided by 3 is 6. Oh, I'm sorry. Wow. Is 8. Thank you. Thank you very much. All right. So here's the bottom. Multiply by its reciprocal. Multiply this side by reciprocal. And you end up getting the same thing. X equals 8. And the reason why you do, this is the same. The reason why I put this here is because the same thing is saying 3 times x divided by 2. It's the same thing as this. These two are the same. Alright, and that's the end. See y'all in class.